This is a graphics final project for an undergraduate class at Northeastern University. I chose to do procedurally generated terrain. The height of the terrain is generated on the fly in GLSL using a Perlin noise function. The textures are not generated on the fly. Those I grabbed from a site on the internet that's linked in the README. Phong lighting is used to light the scene, and normals are computed dynamically. They're computed dynamically because the mesh one is the height is generated in the vertex shader, but also tessellation is used to achieve dynamic level of detail. Let's jump right into the demo then. All right, let's rotate the sun so that you can see that normals are working. All right, let's move all the way up now. A fog effect and a gray sky are used to eliminate the artifacts with the view frustum, clipping the faraway patches. 19 by 19 patches of 16 by 16 vertices are drawn, and those are tessellated from, I think, 1 to 64 within the tessellation control shader. See if we can find some snow. I think that might be a little bit there. See a little bit of specular lighting on the snow there. Also a little bit of the reflection on the mountaintops at the adjacent peak right over there. One nice component about tessellation is that although these peaks looked a little bit rigid back where we were standing about 30 seconds ago, they look nice and smooth now. It was tricky to get lighting working with this setup because you had to construct a TBN matrix in the tessellation evaluator by constructing a small triangle around each point and using the Perlin noise generator to estimate the height at that triangle. From that triangle, a TBN matrix was generated, and the inverse of that was taken to compute the tangent space, viewer position, sun direction, all that stuff, which was then used in the fragment shader to do the lighting. I think there's 5 texture groups. Each texture group has a diffuse map, a specular map, and a normal map. They're blended such that if you're a certain distance away from them, they're sampled at a higher scale, I think like 16, and then when you get closer, they're sampled at a normal scale, and they're blended together based on the distance. So if we move towards this mountain, you'll see the details begin to become easier to see, and that large offset that we originally saw goes down to 0. It's just a cheap effect of reducing the tiling effect that you saw, or well, that I saw before I fixed it. The texture groups are tiled, I think, 3 vertically, and the bottom 2 by altitude oscillate back and forth. They oscillate between these rocks that you see and this grassy effect. And then there's another grassy effect that you saw in the beginning that I think is right up here that's thrown in that mix. See the specular highlighting there again. Of course, the normals. All right. When I apologize for the jerky quality of the video, without using a QuickTime recording, I think the frames per second on a 2015 MacBook Pro is around 30 FPS, but with the screen capture, it's very slow, so I apologize for that. You can imagine if this was in a game, maybe about this move speed would be expected. So as a player moved around, they would, climb a mountain that looked like that in the distance, and about this pace with the correct lighting and the correct specular reflection. And then, all right, so eventually they arrive there, or they fly there because we need to support Grand Theft Auto-like things. And it would look about as good as when they left. All right, now I'll show a wireframe view that shows the number of triangles decreasing. So many triangles were needed to prevent artifacts from the GLSL noise generator from showing through as the level of detail changed that it's hard to tell that it's actually a wireframe and not a textured. But yeah. It's easier to see on walls, yeah. Let's focus on this plane right here. As we back up, we should be able to see the triangles decreasing around that center. There, you can see the number of edges from that anchor right there has decreased significantly. Now it looks like it's about half what it was originally. But we can't see that from here because the fog starts to obfuscate our view. Also, there's enough patches that if I start moving really quickly towards the horizon, you don't see anything pop. They just kind of show up, which is nice. Well, that's it. Thanks for watching.